first one we answered is problem number 4. An arrow is shot straight up from a height of 1.50 meters with an initial speed of 45 meters per second. Now, we are looking for 4 unknown quantities. A. How long before the arrow reaches its maximum height? B. What is the maximum height the arrow reaches? C. What is the velocity of the arrow when it returns to the point where it was launched? And D. How long after launch before the arrow returns to its original height?
In problem number 4, we are given the initial velocity, which is 45 meters per second, and the height from where the arrow was shot, which is 1.5 meters. In order to find the unknown values, the right formulas should be used. With that being said, the formulas we need to use in this problem are the following. In finding the time it took for the arrow to reach its maximum height, we use the formula T equal to final velocity plus initial velocity over gravity, which is 9.8 meter per second squared. Here, the final velocity is 0 because the arrow stops moving the moment it reaches its highest peak. After substituting the values, we now arrive at this equation. T is equals to 0 plus 45 meters per second over 9.8 meters per second squared. 0 plus 45 is equals to 45, and so we now have 45 meters per second over 9.8 meters per second squared. The final answer will be 4.591 or 4.59 seconds. In finding the maximum height, we use the formula y is equals to 1/2 final velocity plus initial velocity multiplied by time. After substituting the values, we should arrive at this equation. Y, or the maximum height, is equals to 1/2 0 plus 45 meters per second times 4.59 seconds. 1/2 of 45 is 22.5. Now, 22.5 meters per second multiplied by 4.59 seconds will give us 103.275 or 103.28 meters. Moving on, in finding the velocity of the arrow when it returns to the point where it was launched, it is really not that necessary to compute for this because we only need to add a negative sign to the given initial velocity, which is 45 meters per second. The reason is because the arrow still has the same acceleration and nothing changes except for the fact that it is now going in the opposite direction, which is downwards. And so the answer for letter C is negative 45 meters per second. Finally, when solving for the time it took for the arrow to return to its original height or to the point where it was launched, we only need to multiply the computed time, which is 4.59 seconds, by 2. By doing so, we will be able to find the time needed for the arrow to return to its original height, which is 9.18 seconds.
A 3-kilogram rock swings in a circle of radius 5 meters. If its constant speed is 8 meters per second, what is the centripetal acceleration? So the given is mass is equals to 3 kilograms, radius is equals to 5 meters, velocity is equals to 8 meters per second. For problem 9, we're looking for the centripetal acceleration. To find the centripetal acceleration, we will use the formula AC is equal to V squared over R, wherein AC is the centripetal acceleration, V is the velocity, and R is the radius. So for the solution, centripetal acceleration is equals to the quantity 8 meters per second squared over 5 meters. The quantity 8 meters per second squared is equals to 64 meters squared per second squared to be divided by 5 meters is equals to 12.8 meters per second squared.